Everybody, welcome to the Gestalt IT Rundown. We had a week off last week, but we've got an exciting couple of episodes, I think. I'm presuming this is all a live IT news show, so maybe it will be a boring couple of weeks to finish out the rest of the year. But this week's really exciting. We got some really cool topics. My name is Rich Stroffolino. I am the content manager with Gestalt IT. I don't know why I had to think about that. That's my job. I do it every day. But I'm joined by the inimitable Tom Hollingsworth, aka the networking nerd. Tom, welcome to the program.
Thank you, Rich. I am glad to be inimitable. It's very difficult to be me on a regular basis. I can't imagine anyone else trying.
I've tried it before, and I have to say it is a fruitless endeavor. So thank you so much for being here. Let's get it started. We had some interesting news coming out from Microsoft. Now, we've covered a couple of their cloud announcements coming up. I'm sure they have some responses maybe to some of the AWS reInvent news, but they actually put out something that's a little bit more out in left field. They put out a preview of Q#, which is a programming language and methodology for quantum computing. And now what makes this really interesting is that Microsoft doesn't have a quantum computer yet. Most of their competitors, they're not really competing yet in this space, but like companies like IBM, Google, D-Wave, all have working quantum computers that they're at least selling or demoing or allowing people to test out on. Microsoft kind of going a little bit of a different approach. They're providing a 40 logical qubit simulator on Azure for people to test out. Kind of interesting. That's quite a few qubits to check out, but they're not looking to put a quantum computer out to the market for another 5 years. Tom, what do we think? By 2022, are we going to be seeing Microsoft selling quantum computers? How big of an announcement is this, and where does this fall in kind of the quantum computing milieu, as it were?
Honestly, my knowledge of quantum computing is much less than my knowledge of quantum leap. So I'm going to have to kind of spitball a little bit here. But I think that Microsoft is kind of going down a good route by doing this in the cloud, by offering people the chance to build on top of a simulator before they make their workloads live. I'm still waiting for a magical usage for quantum computing to materialize. I mean, I keep hearing a lot about cryptography and stuff like that, but realistically speaking, I don't, we can't even embrace the cloud right now, and that stuff we know. Where are we taking this to places we're not sure of?
Yeah, that's actually the most interesting question. The killer app question is always going to be there, right? And then the other question I was thinking about is, okay, if we're going to have this quantum computer that is like many orders of magnitude faster than a conventional or traditional computer, that still has to interface with a lot of legacy things that, like, for example, we're just starting to see the impact of NVMe, like kind of, and software catching up to that and compute catching up to that and what that can do. And that was like one order of magnitude, faster than, serial attached flash or something like that. So when you're dealing with such a huge leap, quantum leap, with quantum computing, that does raise some interesting questions in its own right. I've actually heard that the killer app potentially for this could be in a lot of advanced chemistry studies and finding like efficiency ratios for fertilizer decay and that kind of stuff, and that it could totally revolutionize that industry and totally change food production as we know it, like as one of the more table stakes options out there. If anyone's really interested though in how quantum computing really gets done and how you go about programming for a quantum computer, especially since there's very limited access to one, I really suggest you check out Ray Lucchese and his Silverton Consulting blog. Recently published a really great post giving a high-level overview of how it works. It actually uses the quantum computer, at least so far, as kind of a co-processor in a number of methodologies. There's only like a conditional if statement that's allowable on most current quantum computers. There's a lot of constraints, and it's really interesting how often it has to kind of go back and translate it back into and use traditional computing to make it quantum addressable, for lack of a better term. But to give a kind of a landscape now of where we are at with quantum computing. So Microsoft is doing this 40 qubit simulator. Qubit is like the base unit of quantum computing. It's basically, what is it? It's able to have 3 states, right? Or no, I'm sorry, it's able to do 4 states, right, at any given time. So you can, as you add qubits, you get like exponentially more compute capacity. Again, I'm not going to pretend to be an expert on this, but in terms of where we're at in terms of competition, like I said, IBM, D-Wave are kind of like some of the earlier players. IBM actually has a couple of quantum computers you can kind of go around and actually program on online. They have some cloud quantum computing. They're much lower power than the simulator that Microsoft is having. They have a 16 qubit and a couple 5 qubit pools. I think the 5 qubit ones are mostly the ones that they want the public to kind of play around with. So that's pretty basic in terms of the quantum computing landscape. But it's still out there. They use a different actual software development kit. It's called that uses the Open Quantum Assembly Language, which is all wrapped into the Quantum Information Software Kit. All of these sound really cool because I keep saying the word quantum, but really they're just like rudimentary. Ray compares it to the like the IBM what is it, S360 kind of programming manual, where it's like we're at such a low level with this that we need to, we need to like literally like say like what can these even do for a lot of programmers. We're barely wrapping our heads around the physics of how to build these. Like building these is just a huge endeavor right now. Like I said, Microsoft is still 5 years away from realistically putting one out into production. So it will be it's very interesting though that we're laying the software groundwork for that, and Microsoft being a software company wisely kind of getting out ahead of that.
Software-defined quantum cloud. I do believe that I just hit all of the buzzword bingo squares on your card. So
I just want to give you $75 million in venture funding just for you saying that, Tom. I already do. Next up, and Tom, I think this is something to be a little bit more of interest. Some interesting impacts to the Broadcom Qualcomm potential acquisition. We covered that a couple weeks ago. That Broadcom is looking to do now more of an aggressive takeover of Qualcomm and trying to replace their board of directors. But Microsoft and Google have raised concerns about competition in this space, specifically looking at how this will affect 5G rollout. Qualcomm, being a major chipset provider and being heavily involved in that, and now all this, if Broadcom takes them over, having pretty much a stranglehold on that. Tom, I'm interested on your take on this, how a potential Qualcomm acquisition would affect 5G rollout, both in terms of handsets and more overall infrastructure.
Well, it's a little known secret that most people don't realize that no matter what technology you're using, you still have to build chips to run it. And we start seeing this not just in 5G modems for devices and SoCs for that. I was actually reading an article the other day. They announced that the new iPhone 10 unlocked versions were available, and there was a huge flurry of activity on the forums, not because there was an unlocked phone available. The people don't care about that. They wanted to know what modem was in it, because I guess there are 2 modems. One's done by Qualcomm and one's done by Intel, and the general consensus is that the Intel modem sucks and the Qualcomm one is the one you want to buy. Okay, great. Well, what happens if that's the case for an entirely new product set? And we're talking about LTE chipsets here. So, everybody makes an LTE chipset now almost. But if Qualcomm's the only one making one you want, and now all of a sudden the problem you're running into is that Qualcomm wants to jack the price 10 or 20x because they literally are the only ones you can buy. That's going to slow adoption considerably. Chipset manufacturers can charge whatever they want, and the handset manufacturers either don't have an option or have to, they're going to have to skip this generation, which is not something that we want, given all the marketing that's been going on with 5G recently.
Now, Tom, I have a basic understanding of what the 5G spec or what 5G is supposed to look like, but can you just level set real quick with me, just in case anyone's not familiar with it? 5G, from my understanding, is more based around adding additional capacity versus adding all out, less so than like the 3G to 4G, where that was mostly a speed transition in terms of dynamically fast, bringing broadband speeds to mobile. 5G is more on the capacity end, adding, the ability to connect more handsets to a single node or something like that.
Yeah, that's the problem that we're running into is that realistically speaking, we don't need our handsets to be much faster than they are right now. We're doing data transfer about as fast as we can support. It's kind of like the situation we have in networks when your internal network is running at gig or 10 gig speeds. Your connection to the internet is still limited to, 100 megabits, or if you're really good, a gigabit. So you're not actually getting any faster on the uplink speed. But when it comes to wireless, you do have to worry about the number of clients that are connecting to a given base station, whether it be an access point or a cell tower. And so what 5G is doing is giving us additional bandwidth to cover that. So you'll see things get faster, but not because we've actually increased all the network speeds, but in fact because we've made it so that you're having less contention with people around there. And it's funny for me to say this because it actually wasn't that long ago, but I can remember a time when going to Vegas for Cisco Live required me to turn off the 3G on my phone and drop back down to the Edge network, because otherwise I wasn't going to be able to connect to the cell towers, because it turns out dropping 25,000 geeks on a cell tower is...
Well, that was the traditional San Francisco problem, right, with the original iPhone, right? That AT&T or Singular didn't have the capacity at launch, so everyone was defaulting back down to 2G. So yeah, so very interesting. On a infrastructure end, though, would this acquisition have an impact on like rolling out from a carrier perspective?
Yeah, it will, because the carriers are still beholden to the hardware manufacturers just like everybody else is. And if Qualcomm is a single source of modems for this, and even if they're spending as much time as they can ramping up production, all you have to do is go read the dirt sheets on the launch of any new consumer tech device that's using Qualcomm devices, and just look for things like low yields or bad assembly or something like that, to know how big of an impact it can have when you have one sole source of product for a given, assembly piece. And if they have a bad time and they won't relinquish control, you're going to see a lot of very angry customers of theirs, and that leads to angry customers of yours.
It's very interesting that I saw a lot of the news coverage on this story was saying that this is really actually really beneficial to Apple. One, it takes out, it eliminates a lot of the disputes they're going to be having with Qualcomm over FRAND licensing and that kind of stuff. But it also, they'll be able to, they'll have huge negotiating power with just one player in Broadcom. But then I have to wonder, at a certain point, is Apple then just going to, try to get directly into the, it's cut out the middleman is what they've increasingly been doing, and maybe get into the modem game as well, and then kind of, cut off Broadcom from a huge supplier. I guess when you're the only supplier of 5G, everyone else kind of has to play ball with you at a certain point, but that would be an interesting development.
It would be, except for the two things that made me worry about that is, one, Apple has no desire to do this. Johnny Ive does not want to spend the rest of his life building modems, because those are the most unsexy things that you've ever seen in your life. They're workmanlike. They work, and they're ugly. The other thing is, Broadcom can't afford that, because if you're the only supplier of 5G modems and the largest cell phone manufacturer in the world decides they don't want to buy from you anymore, yeah, 50% of your revenue just hit the toilet. I'm willing to bet Broadcom is literally going to pay Apple to take some of the inventory off of their hands. Now, granted, when I say that, it's probably not going to be much. It's only going to be a few $1,000,000. But this isn't going to be like, two tech giants sitting across the table from each other, staring each other down while Enrico Morricone music plays in the background. This is basically going to be a very hardcore business negotiation.
All right, and next up, kind of along the same vein in terms of lack of competition, there was recently a report that Samsung has increased CapEx expenditures by 250%, excuse me, up to $26 billion for production facilities. And there's a lot of concern going out there that they could basically corner the market on DRAM and NAND, largely, and this largely has to do with the basic exit of Toshiba and the falling apart of their entire flash production capabilities. I mean, not related necessarily to that. They were successful, but they sold those off due to their horrible investments in nuclear energy for under 500 million, something like that. So I mean, Samsung is investing in fabs, really getting into doubling down on production. Is this just an inevitability at this point?
Samsung has a lot of things they want to put those NAND chips in. It's not just a matter of, we want to put these in SSDs and corner the market, or even, PCIe flash or NVMe. Look at the number of phones they sell. And if every phone has a flash chip in it, or multiple flash chips, I mean, that's a huge market right there. But the funny thing about this, because I hear it time and time again, some companies trying to corner the market, some company is trying to, make sure that they are the only supplier. And the funny thing is when there's only one or two people in a market and the prices are high, that encourages people to get into the market. Now, it's a little different when you have to make a huge CapEx investment in order to be able to have those plants to make things. But you'll find that some people are going to start nibbling at Samsung's heels. This isn't going to be a situation where they're going to allow to have a monopoly on the world of flash storage.
But you could argue that there's already been that incentive for a lot of companies. I mean, we've kind of over the last year and a half been going through a NAND shortage, and we haven't. I mean, at least on my from what I've been seeing, haven't seen a ton of players jumping into that market. If anything, I think Samsung says, hey, we can come in, we can be the good guys, lower the overall prices in the market, and just soak up some easily soak up some market share just by adding capacity.
This is the same problem that happened to the DRAM market years ago. Whenever there wasn't enough DRAM, and then everybody spun up fabs, and then we were drowning in it. And now we're back to an equilibrium point. But it's the thing people have to understand is that there's no such thing as a stable market. If you believe in that, I've got a small bridge full of Bitcoin that I'm willing to sell you. Markets expand or contract. There's always a shortage or a surplus. There's never an equilibrium point, because as soon as we reach an equilibrium point, somebody is going to try to either short the market or try to do something else that's going to cause it to destabilize.
Well, and then there's always the specter of something disrupting DRAM or NAND entirely, down the line. Obviously, that's not something that's going to happen next year, but, we're seeing more and more, NVDIMM technologies coming out. We're seeing, I was just looking into a silicon oxide ReRAM company startup, a couple of those that are kind of getting into those weird esoteric RAMs. Eventually, I feel like one of those has to take off and maybe not disrupt the consumer market, but disrupt, the real high-end stuff. So that's always, I guess, a concern as well. So maybe just a passing concern at this point.
Yeah.
All right, and finally, kind of the last story I thought was really interesting. Like I said, we covered a couple of weeks ago most of the major announcements coming out of AWS reInvent. There's 10 billion announcements, so I'm sure we missed just a couple 100,000 of those, checklist features that they added on there. But really interesting, we had talked a while ago about Amazon kind of having to sell off a lot of their hardware assets in China due to regulatory requirements. Basically, the Chinese government wants Chinese companies to control the hardware. Amazon can kind of still be in the management perspective, kind of be over the top with services, but had to basically give up all of their hardware. And now Amazon has announced that they're partnering with a company called, let's see, Ninjixa, to expand their cloud offerings in China. And basically what they are doing is it's basically the same kind of partnership, except coming in reverse. Instead of having to sell off their hardware, they're coming in, they've given the company their own specifications for exactly how to build an AWS data center. They've already built it, and they're going to run their services on top of it. Is this, and the thing that I think this is interesting, you could spin this one or two ways. This is either it's impossible to compete in China without, being in bed with a Chinese company. The regulatory, it's just too burdensome. Or is this Amazon being like, hey, we figured out how to rake in the bags and bags of cash, and we're just going to do this until, okay, maybe AWS is run on 10 different companies' servers, but at the end of the day, Amazon's still getting a cut of all that.
I think of this in the way that I imagine that every other company in the world that thought they figured out how to sell into the Chinese market, if you walk out the back door of these local Chinese companies and you see the littered graveyard of ventures, that will tell you everything you need to know. This is not Amazon magically figuring out how to crack the Chinese market, just like Apple couldn't, just like Google couldn't, just like IBM, Cisco, any number of companies. It's the same pattern over and over again, and the Chinese have it honed to an art. You have to partner with this company. You have to give them all of your secrets. They'll give you a little bit of money, and the next thing you know, you'll find out that your investments and your customer base slowly start dwindling, while this company's investments and customer base slowly start rising. And at the end of the day, you have, well, think of the number of things that you've heard of in the news that have the definition of the Chinese Uber, the Chinese Google, the Chinese Twitter, the Chinese Facebook. That's your answer.
Wow. Do you think that this could be a model, though, to kind of reverse engineer it, right? To get Chinese companies kind of embedded or get a foothold into a U.S. market where you would have a company like Alibaba or Cloud or something like that, do a partnership with a much smaller company that has a U.S. footprint. Because right now, the big hurdle is, yeah, you have these giant companies in China that are, that dominate markets. Like, again, Alibaba represents 80% of the cloud market in China. But they can't get a foothold in the U.S. for a variety of reasons, some cultural, some legal, a lot of regulatory issues going on there. I know that's a huge problem with any hardware companies directly coming out of China. So do you see that as kind of like a way to get in, where partner up with a small, cloud company that's never going to carve out significant market share, and all of a sudden you're backed, by this Chinese giant?
Yeah, that could work, but I think the biggest hurdle that you mentioned is regulatory. This is something that I saw years ago with Huawei when they tried to get into the U.S. market. Boy, you say you're doing a project with Huawei, and all of a sudden a bunch of unmarked sedans and nice gentlemen with glasses and bulges right here under their shoulder want to ask you a whole bunch of questions about what's going on and who did you talk to and what are you going to be putting on this, and I hope you're not putting any of our data on this. I have a feeling that it's going to be the reverse problem, where the Chinese want to encourage that kind of partnership for reasons of taking intellectual property, at least in my own personal opinion. I'm not a lawyer. I think that the reverse truth is that the U.S. government will not allow Chinese companies to get a foothold in this country because they fear that the Chinese company would either take off or, worse, take everything.
Yeah, it's really interesting though that you mentioned, like the Chinese Uber. There was just a story coming out a couple of days ago that GD Shushing, the company that kind of bought out Uber's presence in China, is still partnering with there's still a partnership going on there. But again, it's very much along these same lines, where it's, hey, you give us all your IP, we'll cut you in for a small percentage, and we're just going to roll because, one, we know the lay of the land. Two, we know who to talk to get through regulatory approvals. It's arguably a impossible nut to crack for anybody coming in cold. I mean, we kind of already went through this with the search engines going through there, in the late 90s, early 2000s, and Google made a hard exit. Microsoft had to basically play ball to even stick a presence, and you could argue that did them more harm on a public relations front than good. So it is very interesting.
Mm-hmm.
All right, well, that just about does it for the rundown this week. We are live every Monday at 12:30 p.m. Eastern, me and Tom Hollingsworth. You can check me out at Gestalt IT. A lot of my writing is there, gestaltit.com, your home for IT coverage from across the enterprise. You can also follow me on Twitter at Mr. Anthropology. You can follow Tom at Networking Nerd. Lots of really great stuff and snark, I'm told.
A little bit.
Okay. All right. Well, if you have anything that we need to cover, you can shoot me, find me on, please don't shoot me, but you can send it to me on Twitter at Mr. Anthropology, or I have my email address on Gestalt IT. I really don't want to say it, but find it there. Leave a comment on anything that we write. Follow us on Facebook, facebook.com/Gestalt IT. And until next time, we will not see you because we're on the internet. Take care.